physics P6 relays, which are electromagnetic switches. So relays are practically, they have the same role as a switch in a circuit. Uses for safety in a circuit. What are they doing when a low power circuit, which is a safe circuit for us, turns on a high power circuit, which could be dangerous for us. Now, at the point where it turns on, this is insulated, otherwise it wouldn't help the first one being safe. So we have one circuit and we have another circuit, and they're insulated by something, but yet the first one affects the second one when the first one keeps us safe. Now let's see how is that happening. Well, I'm gonna get the circuit and I'm going to draw so here is the circuit, positive, negative. This is a low power, let's say 3 volts, low power, so the current is going this way and then the current is going back that way. What is this piece over here? This is an electromagnet. What is an electromagnet? An electromagnet practically is a piece of wire that's coiled, and it has a core inside to make it stronger. So I'm gonna say coil of wire becomes magnetized with current. So that means I need to be able to hook this to a power pack. This was the experiment that you've done in a lower class where you picked up paper clips. Okay, so you get the current going in. When the current goes through the wire becomes a magnet. If you have that core, the magnet becomes even stronger, so you can pick up things. Now you create a magnetic field there. Now, something that we need to know about an electromagnet, this is a bit of a revision. Electromagnet becomes stronger. That means it's a stronger force, like it's a stronger magnetic force there. If, well, let's look. If I'm adding more loops, it's obvious that I will have a stronger magnet. So more loops. For example, let's say from 20 to 80 loops. Number n, 20 to 80. This will increase, it will make the electromagnet become stronger. Okay, stronger core, a thicker core. Usually it's iron, which is a soft magnet. And the third thing I can do, I'm adding more current. So I'm going to move, for example, from 3 volts to 12 volts, which will increase the strength of this electromagnet. So current is coming to the electromagnet. This becomes magnetized. That means it can attract things that are in its vicinity. So let's say here we have a strong bulb. This is this is negative. This is a 24 volt power pack. So here things can be a little bit dangerous for us. Sorry, I'm just gonna go up here, so ignore this section. So I'm just gonna label these parts. I have part 1, I have part 2, and I have part 3. So what's happening here? let's see, number 1, current on, so this is number 1, in circuit, the one on the left. Number 2, well, if the current is on, this electromagnet becomes magnetized. So electromagnet is on. So there is a field there that can attract things already. Number 3, well, this field, what will the field do? For number 2, it will just move these two ends together. So ends of switch come together, and then current is on in the circuit to the right. So very simple. I get a current going on, it goes through the electromagnet becomes magnetized, it will pull these ends together at point position number 3. When these ends are pulled together, the light bulb is on, because this circuit is on at this moment. Now when I turn off the current on the left, electromagnet loses its strength as a magnet, so the leads 2 and 3 will move apart one from another. Current is going to be stopped in the second circuit. So you see here where I'm talking of safety, I'm doing something on the left with the help of an electromagnet. I'm just moving a couple of leads on the right circuit, but those two circuits are never in contact one with another.